Hello everyone, I am Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So we are in the course of electrical measurements and instrumentation. So here in this last class we learnt about extension of meter ranges, how shunt series cases will take place, and how multiplier circuits are employed on measuring instruments. So these are the aspects we covered earlier class. So based on that, we deduced some relations in shunt and series manner when resistance is connected in such a manner. Then we will suppose to do some numerical problems based on the meter ranges. So coming to extension of meter ranges, usually to extend the measurement range of the ammeters or voltmeters, shunts and series resistances are usually considered. So for this, if you go with the shunts, low value of resistance is connected, that is in parallel with the ammeter case, and we have divert excess current is going to be injected into them. If it is the case of series resistors, high value of series resistors are connected in series with the voltmeter. This is because of to limit the current flow going through the meter case. So based on the assumptions or considerations, we can able to make sure about extending the meter range. So this is a simple example which will better explains how meter range can be inserted or extended with the shunt case. So here it is given like this: 2 milliamps of ammeter that should be designed with internal resistance about 100 ohms. This is to be converted to 0 to 150 milliamps with the ammeter case. Here we need to calculate the value of the shunt resistance required to maintain. So the values are given like this: 2 milliamps means that is IM, current value 2 milliamps. So resistance is about 100 ohms, meter resistance 100 ohms, and it is to be converted into 0 to 150 milliamps. So 0 to 150 means total current I, that is 150 milliamps. So here we need to concentrate on shunt resistance required, that is to be RSH. So RSH is IM RM by I minus IM. We already deduced the relation in the earlier class. The shunt field resistance is IM RM by I minus IM. So coming to IM value, this is about 2 milliamps, 2 into 10 power minus 3 into RM is about 100 ohms, that is 100, 2 into 10 power minus 3 into 100 by I minus IM. So what about I value? 150 milli. So 150 into 10 power minus 3 minus IM is about 2 milliamps. 2 milliamps means 2 into 10 power minus 3. So in the numerator side we have the value of 2 into 10 power minus 3 into 100. In the denominator 150 into 10 power minus 3 minus 2 into 10 power minus 3. So when you make sure about the calculation of these cases, we can able to obtain the shunt field resistance value is about 1.351 ohms. So this is the value of the shunt resistance required to maintain the circuit. So by this we can extend the meter range. Here is one more example. Design a multi-range DC milliammeter with a basic meter having a resistance of 75 ohms and full scale deflection of 2 milliamps of current. They about to require the ranges 0 to 10 milliamps, 0 to 50 milliamps, and 0 to 100 milliamps. Here we require to design a multi-range DC milliammeter. This is with the basic meter having the resistance 75 ohms. And also full scale deflection of the current, that is about 2 milliamps. So the ranges are given up to 10 milliamps, 50 milliamps, and 100 milliamps respectively. So here we will suppose to do it with the first range about 0 to 10 milliamps. Then this current is considered as I1. I1 is about 10 milliamps, and your meter current is given about 2 milliamps, full scale deflection. And meter resistance is given 75 ohms. Then you need to calculate the first resistance R1. So applying same condition, Im Rm by I1 minus Im, where Im is about 2 and Rm is about 75. I1 minus Im means 10 milliamps minus 2 milliamps. All are in milli. So straight away we can take the numericals. No need to take into 10 power minus 3 here. Straight away we can take direct digits. Here 2, here 10, here 2. So when you substitute for this, you can able to get R1 18.75 ohms. The second range is about 0 to 50 milliamps. That is with the current I2 with the 50 milliamps current, and your R2 becomes Im Rm by I2 minus Im. So Im is about 2 into Rm is about 75 by I2 minus Im. I2 is here given with the current, second current 50 milliamps. So 50 minus Im is directly 2. So 150 by 48 means 3.125 we can able to expect as second resistance, that is R2. And coming to with the third range about 0 to 100 milliamps. Your third current is 100 milliamps. Your R3 becomes Im Rm by I3 minus Im. Im is 2 into 75 by I3 is 100 minus 2. So 1.53 ohms we can able to obtain as R3. So the designed multi-range ammeter with the selector switch is represented here. This is the selector switch. So these are the values we calculated: R1, R2, R3. R1 is about 18.75 ohm. 18.75 ohms. And R2 is about, here R2 is given, that is about 3.125. 3.125 ohms. And R3 here 1.53 ohms. So these are the values we obtained. With these values we can able to design a multi-range ammeter. Here it is shown in the diagram. It contains a selector switches and meter resistance R. We have one more example to know about the meter ranges. So that is moving coil instrument gives full scale deflection. Its current is given about 40 microamperes, while the internal resistance of the meter is about 500 ohms. So it is to be used as a voltmeter ready to measure the voltage range about 0 to 10 volts. So here we need to calculate the multiplier resistance required. So here given values are Rm, which is about 500 ohms meter internal resistance. Im is 40 microamps and voltage is 10 volts. Now your multiplier resistance you can calculate here as Rs V by Im minus Rm, which is equals to V means 10, Im is 40 into 10 power minus 6, minus Rm means 500. So when you substitute all these values, you can able to get a value of 249.5 kilo ohms. You can able to get in kilo ohms. So this is the value required to maintain in the multiplier circuit as a multiplier resistance. You can take Rs or RM, this multiplier resistance. Multiplier resistance. So this is the amount of resistance we require to maintain in the circuit. So likewise, we have so many examples based on the extension of meter ranges which can give suitable values like this here, calculating about RM and RSHS and using as a voltmeter. We can able to solve so many problems that gives the suitable solutions to extend the meter range. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.